So yeah, Scalable API security using OAuth is the title. I'm not going to talk much about OAuth today. I'm going to talk about OAuth tokens mainly. My name is Daniel. I work with Curity. I work as a solutions architect in Curity, which means that I'm working with our customer projects mostly, helping them building a secure API platform. I'm also using OAuth and OpenID Connect. And since a few years, I've been doing different workshops with Nordic APIs on OAuth and OpenID Connect. So I've been at Nordic APIs a lot. And today is the topic, the access control in an API platform. And I'm going to talk about how to enable that using claims and scopes, typically, and I'll talk about a pattern that we often use with our customers that we call the phantom token flow to enable the scalable platform. So first of all, we need to talk about permissions and how do we express those permissions in an API landscape. There are several types of permissions that can travel through your system, and we need to somehow unify them and make them easy to understand and to enforce. And it comes as no surprise, Curity likes our tokens, so we are going to use the tokens as the information bearer for those types of permissions. And if you're familiar with OAuth, you know that there is a parameter called the scope, which roughly translates into the client permission. The token has a scope of access, and it is configurable for the client. The client can ask for different types of scopes. And the definition of these scopes is up to the implementation, I would say. OAuth just says that they're strings. So in this token, we have the scope list releases, which kind of implies that using this token, we can call some API and get a bunch of releases back in a list. Since scopes are just strings, and if we're using this strategy of having a list release scope, we have the problem of what if we want to add something? We need to add a new scope for add releases. And the same thing, if we want to delete something, we will have to delete scope. And we add another API that we need to read and we need to add accounts for. We need a bunch of different scopes for each API. So this method usually works out fine in the beginning, but when you have 100 APIs, the scopes tend to get hard to manage. And it's hard to keep track of what scopes you have in your system. So we've seen a bunch of different ways of managing that, and one of them is the hierarchical scope, right? Where you define some kind of hierarchy of scopes, where the top level to the left kind of translate into your product, and then some sub areas and the feature, and basically the longer scope you have, the less powers your token has. So the second example there being that this token can only read feature 2, and the second from the last, the product 2 scope means that I can do anything in product 2. I can read and write to all of the sub areas and things like that. That's one way, but it also means that we have a lot of different scopes in our systems. Another way is resource URIs. We're saying the scope is basically the URI of the resource that we are trying to update or read. It kind of has the same problems with the methods, because if we have a URI for a method, then that means that does that mean that we can read or write or both? So we need to add some kind of method in there, and it keeps growing. Not saying that these are bad methods, just trying to point out that there's still a problem with them. There's probably easier to have something like this than to have 1,000 different random names and scopes. But since we have this problem, we usually try to keep scopes at a minimum. They're hard to maintain when they grow, and we even have what usually happens in an API platform is scope explosion, because you start out with one API that needs 3 scopes, and then you add on, and the scopes tend to explode. So one other way of describing the permissions in a client is the user permissions. So a client that has access to a list release scope we can also have a more finer grained of authorization using the user that is currently using this application. So we could also take into consideration the user claims that can travel within a token. So in this case, we have Daniel, that I'm a part of the local admins group, and I'm working for the development department. This could also weigh in your authorization decision. And claims can be seen as a scope can be seen as a group of claims. OpenID has a definition saying that if you have the profile scope in a token, that kind of means that you will get profile data in the token. So things like preferred username and given name and family name will end up in your token if a client requests the profile scope. And a similar way can be done for this list release scope. The list release scope can be resolved into two different claims, the groups and the department that I'm working on. So in this way, we can look at the whole token. We don't just use the scope, which is what OAuth usually says, that scope says permissions. We can look at the groups. In this case, we have the release API, which has a policy that says that if you are going to post to this API, you have to be part of the release admins group. If you're going to read it, it probably is enough if you have the release scope. So let's have a look at how we can enforce this. We usually enforce this in what it's called, the levels. We start with the coarse grained. Usually all customers have some kind of API gateway or at least a reverse proxy in place. And when we're trying to get to the APIs, we can do some kind of authorization already in the API gateway. We call this the coarse-grained access control, and we mainly want to have a policy there saying, answering the question, what can the client do with this token? So have a look at the scope, for instance. We have the list releases API, the release API on the right-hand side. To get there, you need at least the list release scope. If you don't have it, you can block it right at the door. So, but if you have it, we can let you through and pass on to the API. And then the API can have a look at the full token and make the finer access control decision. Where, since the API can have access to the full policy, either by compiling code or using some kind of centralized authorization system. But the input to the policy is the token, where we have all the user claims and we have the client claims, and we can make the full authorization decision based on that. So in this case, we were accessing the release API. I'm part of the development group or local admins group, and you're allowed to see the data. But what about PII in this picture? There's a lot of PII in user claims, and if you're in Sweden, it's very likely that you use a bank ID for authentication, which means your personal number is floating around here, right? So we need to hide that somehow. And in OAuth, we have opaque tokens, which doesn't contain any data at all, so it's easy to hide that data. It's merely a reference to a database somewhere. We call it a reference token. So when this is used against the API, of course, the API won't know what this means either, so it has to ask the OAuth server. So what does this token contain? And we'll get back the full data that we saw before. We have the user claims and the client claims and everything in there. But this makes it a little less scalable, since all of the APIs in your platform will have to call the OAuth server to ask, what is this token all about? And that leads us on to the phantom token flow. If you've been here before, you probably heard me or any of my colleagues talking about phantom token flow, because this is something we use at all of our customers because, well, we think it's very good. In the phantom token flow, we introduced the API gateway again. It's not a product, it's a conceptual thing. Everybody has at least a reverse proxy, so we can use that for the phantom token flow. But it starts off with the reference token being issued to the client. Still no data here. You can bash on it for as long as you like. You never find my personal number. And when this token is used to call the API, the reverse proxy can intercept this call and do the validation for us. So it sends it to the OAuth server and asks, is this token valid? And if it is, it returns the data. But in this case, it's just not the data about the token. It returns a new token or the same token in different format. Instead of using the reference token that we had before, it returns the value token, which is a JOT, a JSON Web Token that's signed by the private key of Curity. And that is the token that's then being passed on to the API. So this means that the API can validate the signature of this token and use the data that's in it if it's valid and base its authorization decision on top of that. So what we enabled here now with this flow is that on the left-hand side, on the evil internet, we have reference tokens that don't contain any data. We have on the right-hand side all the data that's needed for the authorization decision or as input to your policy engine. And we have the API gateway in the middle doing coarse-grained authentication, well, authorization. And all of these components can do everything by themselves but without calling out to third parties. That's about it for my talk today. But I also want to mention that we are loading out a Nintendo Switch in our booth after this talk. So if you had time before that, go into this URL and register and be in the lottery. So thank you.
All right.